All right, everybody. I've got 15 minutes to complete this activity. Hopefully you're staying warm. It is cold outside. And if you're wondering, if you do throw boiling water up in the air, it does turn instantly into snow. But make sure the wind is not blowing back at your face, because I almost made that mistake. So for off-campus day, the first part is signing up for Khan Academy. I hope you've done that. Now for this second part, all you have to do is follow along with me and kind of soak in as much information as you can and work through these notes and then submit the notes once they're completed. So it looks like a worksheet, but we're using this as notes to make a few connection points. So these are all linear functions. They're all having to deal with lines. Just make sure you're imagining everything is a linear function. Number one, each question gives us a different style. Number one says, suppose that the function f of x equals 2x plus 12 represents the cost to rent X amount of movies from a month from Netflix. Back in the day when I had Netflix, you used to have to just rent a few movies a month. Michaela now has $10. How many more dollars does she need to rent 7 movies? Well, if X stands for movies, we're just going to plug in a 7 into that spot. 14 plus 12 gives me 26. She only has $10, so she needs $16 more in order to pay. So that's just one where, hey, you need to know what X stands for. You need to know what that stands for. In this case, that stood for the cost. So you have to kind of navigate the situation. All right, moving on. Number 2. The table shows the average weight of a type of plankton after several weeks. So we've got weeks on the left. We've got plankton on the right. That's going to be X. That's going to be Y. What is the average rate of change? So the slope. Fancy way of saying slope, in the weight of plankton from week 8 to week 12. Well, if we've got week 8, the plankton weighed 0.04, and if we've got it week 12, the plankton weighed 0.49, then ladies and gents, we've got 2 points, and we can find the average rate of change by using the slope formula. y2 minus y1 over x2 minus x1, and then we've got 0.49 minus 0.04, that's 0.45. I'm ashamed I used a calculator to do that. And 12 minus 8 is 4. Then when we divide this, we get 0.1125 ounces per week. How did I know ounces per week? I just went back and looked at my table. Ounces per week. So average rate of change is simple slope. Moving on down. David compared the y-intercept of the graph of the function. Okay, see, y-intercept of this function, which we know to be 5, to the y-intercept of the function in the table. What's the difference in the y-intercepts? So this one makes you kind of take a roundabout way. They gave us this first function right here, the one that I'm putting the squiggly under, and we know the y-intercept is 5. Then they gave us a table. So what I'm thinking is I'm going to use the coordinates on the table, come up with an equation, then convert it to slope-intercept form. And then we'll have my y-intercept. So let's do that. I'll use the 2 points that have the smallest numbers. So y2 minus y1 over x2 minus x1. So I've got 1 over negative 1 plus 3 is 2. So I got 1/2 as my slope. Okay, and if 1/2 is my slope, then now I need to put it in point slope form. So y minus y1 equals 1/2 x minus x1. There's my equation. But I still can't tell what the y-intercept is, so I need to convert this to slope-intercept form now. So I'm going to distribute, and I'm going to get y minus 5 equals 1/2 x plus 1/2, and then I'm going to add 5 over, and my final answer will be y equals 1/2 x plus 5.5. So they told us what's the difference in the two y-intercepts? Well, if this one's 5.5 and this one's 5, then they have a difference of 0.5. Explain your reasoning. The work off to the side kind of shows how we found the equation and the y-intercept that way. I think another way you could have done it is the y-intercept. If this was a 0, actually, yeah, with a y-intercept, the x is always 0. So if we look at our pattern, it's going -7, -5, -3, -1. Technically, this would be +1. Then we look over here at our pattern. Up 1, up 1, up 1, up 1. Hey, so check this out. This works too. If from -1 it's 5, and then at +1 it's 6, then if we squeezed a 0 in, like right there, what would go here? What's right in between 5 and 6? It's 5.5, like we found mathematically. So whatever way you want to do it, reading the table, reading between the lines, understanding what a y-intercept is, that's when x is 0, it all works. But so does the math off to the side. Okay. Let's move to the next problem. I know I'm going fast, but hey, you can pause and rewind and watch it again if you need to. The boiling point of water. Hey, I was just talking about that. The boiling point of water, which is T, that's important actually, at an altitude measured in feet, that's important too. So T measured in degrees, altitude measured in feet, is modeled by this function right here in the box. In terms of altitude and temperature, which statement describes the meaning of the slope? Oh, this isn't bad. This is the slope right here. I'll highlight. That's the slope. And it's measured in feet. And it's talking about boiling point. Ah, and look what they did. This is 0.0018. And then look at our answers. They're just normal 18, 1.8. But instead of being feet, they're in 1,000 feet. So we need to move the decimal 3 places in order to understand what they're trying to do here. Because if they're talking 1,000 feet, then we need to go 1, 2, 3. So we'd actually have 1.8 would be our slope. And since it's a pot, oh no, look, there's a little negative over here. Yikes, I almost butchered that. It's a negative slope. Okay, so that means that the boiling point is going to be decreasing. So it's automatically one of those two. And it's not going to be 18 degrees. It's going to be 1.8. Because we just moved the decimal place 3 places because it says 1,000 feet. So that's 3 zeros. So we moved it 3 places. So I'm going to have to say the answer to this one is D. All right, moving on. We're about the halfway point in my time limit. So I have extra time. I'll slow down and go back and make a few more connection points. The table below shows the distance that a car has traveled. So obviously we're focusing on reading and interpreting tables here, which tables are used all the time in the real world. The ACT I know loves graphs and tables, so we need to be able to interpret. Notice this one's more horizontal. We've got minutes, which is probably my X. We've got distance, which is my Y. And the table shows the distance that a car has traveled. Oh, there we go, in miles. I was like, how do we know our unit? So after 25 minutes, it's gone 20 miles. After 50 minutes, it's gone 40 miles, and so on and so forth. Find the slope of the linear model and explain what it means, more importantly. Well, hey, I'm hoping that you guys have realized that when you have some data, what you have is you technically have an ordered pair right here. You have the ordered pair 25, 20. And then you have ordered pairs right here. I mean, all the way down is an ordered pair. So we have the point 50, 40. And if I need to find the slope, the rate of change, I'm just going to do my y2 minus my y1 over x2 minus x1. And I get 20 over 25, which can reduce. 5 can go into both of those. So I got 4/5. Okay. So what does that mean in the context? Well, that means, since we put y's on top, this is 4 miles every 5 minutes. If we really wanted to go farther, then that's if we divided those, 4 divided by 5, you get 0.8 miles per minute. 0.8 miles per minute. So that's almost a mile a minute, which if you're going 60 miles an hour, that's about a mile a minute. So this car is probably going around 55, 50, right? So that's 0.8 miles a minute. At first I was like, that's really slow, but no, that's not 0.8 miles per hour. That's 0.8 miles per minute. And I found that by using slope. All right, moving on. Lucy and Adriana began saving money the same week. The table below. Is that your tea? Are you boiling water in there? You guys hear that noise? My wife's making tea, so sorry about that. Lucy and Adriana began saving money the same week. The table below shows the models for the amount of money that they saved after blank weeks. So here's Lucy's savings. Here's Adriana's savings. And let's talk about them, because I want you guys to just be able to realize, hey, Lucy's saving $10 a week. Adriana's saving $7.50 a week. But Adriana started with more cash than Lucy did. I'm hoping that you understand what slope means in context now. After how many weeks will they have the same amount of money? Well, hey, if we have a function for Lucy and a function for Adriana, and we need to know when they are going to be equal, let's just take Lucy's savings, what represents Lucy's savings, and set it equal to what represents Adriana's savings. And now we have a little equation that you've been doing for years. Subtract 7.5 over, and we've got 2.5x equals, subtract the 5 over, 20. X equals whatever 20 divided by 2.5 is. That's 8. So after 8 weeks, they'll have the same amount of money. Then my question is, if you plan on working for 3 months, whose savings would you rather have after 3 months? Hoping you said Lucy, because this is after 2 months, they're equal, and Lucy's definitely going to pass her up because she has a slope of 10. All right, perfect timing. Last problem. There were originally 4 trees in an orchard. Each year, the owner plants the same number of trees. That is actually really important, because that means it increased by the same number. It's a constant rate of change. And one of the concepts that you need to understand about a linear equation is that linear equations have a constant rate of change. Look at that line. It went up and over the same amount. So that's actually a big tip if you were to see this problem on the ACT. When it says the owner planted the same number of trees each year, that's a crucial sentence. We know this is a linear function. In the 29th year, there were 178 trees. What is the rate of change of trees in the orchard? And then write an equation in slope-intercept form to model the amount of trees in the orchard. Well, hey, this is a perfect question to end this sheet on. If there were originally 4 trees in an orchard, so in year 0, there were 4 trees, right when he planted the orchard. And then in year 29, there were 178. That is the math piece that you got to remember. You can make coordinates. Okay, that's what coordinates are, is they're representations, visual representations of data. So we're going to we need to find our slope, y2 minus y1 over x2 minus x1. We've got 174 over 29. Can't do that one in my head. And we get, wow, it works out perfectly. We get 6. So what does that mean? That means he increased 6 trees per year. We need to write an equation in slope-intercept form. We got so lucky. Because one of the 2 coordinates that we happen to have is the x-intercept. The y-intercept. The 0.04 is the y-intercept. So we can say y equals 6x plus 4. This equation models our orchard. All right, guys, go back and watch that if you need to. I'm hoping that this helps you kind of see slope in real-world situations, looking at tables, data, graphs, etc. If you need to rewatch this video, you can, but make sure that whatever notes you just took, you upload that and submit it for your off-campus day assignment. Don't forget Khan Academy. Register. Peace.